Hi everyone, welcome to this week's tips and tricks video. Today's topic is truncation management in Paleoscan. This is the latest feature in Paleoscan 2019 and it will allow you to define truncation in a stratigraphic model which was built directly from the 3D relative geologic time model, also known as 3D GeoModel or 3D RCT model in Paleoscan. This truncation tool is a part of the sequence stratigraphy module. So in order to use it, I will need to go to the extension tabs and activate this advanced interpretation add-on license first. And then I'm going to the module list and select the sequence stratigraphy module. After that, I'll need to build a stratigraphic framework. To do it, I'll go to the toolbar here and click on the first icon, which is the new Strati viewer. The input will be the 3D GeoModel. Just one click to select. So the Strati viewer will allow me to define layers, sequence boundaries, horizons, and to build a stratigraphic model in a short time frame directly from the 3D GeoModel. And then I hit OK. So this is the Strati viewer interface. I'll expand it a bit. The reference model or the input model is the 3D GeoModel I just selected. And below it, you can see here, this is a displayed attribute box. So basically, if you have any seismic attribute which can help you with defining sequence boundaries, you can bring it into here. For example, I can display my seismic attribute as a background just by drag and drop it from the volume folder on the left here into this box. So this is the Maui 3D offshore New Zealand. Because the 3D GeoModel was computed directly from the 3D seismic volume, so here is the Strati viewer. I will have an option to flatten the seismic volume using the 3D GeoModel as a guide to transform it into an interactive Wheeler diagram. The shortcut is T. As you can see here, this is the Wheeler diagram. Maybe I can change the parameter a bit in order to make it nicer. Right. I can easily switch back to the seismic domain by press T. So you can see this is the Wheeler diagram, and these gaps in this diagram show you the time of non-deposition or erosion in the 3D seismic volume. You can see here. And this tool will help you to better identify the sequence boundaries, erosional surface, and the best part is that I can pick the sequence boundaries directly on this diagram. What I can do now is I'm going to define a new sequence or new framework for my picking. I go to the toolbar and select the third icon, which is the new sequence here. I put a name on it. You can see there is a new mask mode, which is the stratigraphic sequence picking mask mode. I can drag it inside the Strati viewer to display the isotime horizon as a green one here. This is the isotime horizon from the 3D GeoModel. And because you have the relative edge values everywhere at every pixel in the 3D GeoModel, you can display the isotime horizon at any locations just by dragging inside the Strati viewer like this. And then I'm going to the location I want to define a new sequence boundary. Here is the top of the gap in the Wheeler diagram. I can double click on it in the viewer in order to define a new sequence boundary at this location. And then I can go to another location, just double clicking on the viewer to define a new one. And you can see here a new layer was just automatically created between them. I can also easily go back to my 3D seismic domain to see how my sequence looks like in the 3D seismic domain. So what I've done is in 3D, not only in 2D actually. And you can see here a new layers or sequence was just created. I can also pick the sequence boundary in this 3D seismic domain. Again, just double clicking on it, on this viewer, to have a new sequence boundary and then a new layers here. By doing that, I can create more layers. Just hold down left mouse and drag inside the strategy viewer to display the actual time horizon. And then double click on the strategy viewer to create a new ones. Like this. You can see the actual time horizon appears everywhere. So now I created some layers from my stratigraphic framework. Because the boundaries are actual time horizons from the 3D GeoModel, they are fully interpolated and never get truncated in this case, even when you have a top set like this. So this is the actual time horizon at the top set area, and all the horizon below it, at the foreset area, will never intersect it. So let's have a closer look. So at this location, I would have a truncation in order to honor the seismic geometry. However, when I display the ISO time horizon here, you can see they are all continuous and never intersect each other. So in Paleoscan 2019, you will have a new tool to define the truncation in this case. So the new truncation tool is located here in this strategy viewer. I will need to activate it first in order to have stratigraphic truncation. Then I go to the toolbar and activate this truncation mouse mode. So you can see a new kind of cursor appears. This is the truncation mouse mode. I can drag it inside the layers like this. You can see the thickness of the cursor is automatically adapted to the thickness of the layer where I put this. And actually the thickness of the layer at here where I put the cursor is also defined as a thickness threshold. So all the areas with the thickness lower than this threshold will start to be changed. Here you can see I put the cursor at the location I want the truncation to begin. And then I will have two options for the truncation direction. On the toolbar here, you can see the first one is the truncation top, and the second one is the truncation bottom. The truncation top means the top boundary will become a reference horizon, and the bottom one will be snapped to this top one, and vice versa. The truncation bottoms means the bottom horizon will become a reference horizon, and the top one will be snapped to this bottom one. So in this case, let's say I want to have a top left, so I would choose the truncation top. You can see I just defined a new truncation based on the thickness threshold, which is the thickness of the layer where I put the cursor here. I can also see the parameter in the truncation list. So I will click on the edit option here underneath the truncation mode. And you can see this is the truncation list, the one I just created. And you can see there are some parameters here. The first one is the truncation type, in this case it's the truncation top. The second one is the truncated horizon. The third one is the reference horizon, which is the top one in this case. And you can see the thickness threshold, which is the thickness where I put this cursor. And the last one is the distortion strength, is how aggressive the truncation. So you can see the truncated horizon, which is the bottom one in this case, was highlighted in red. And the top horizon became a new reference horizon. I can rename them if I wish by selecting it. So I would double click on the horizon and then put a name on it in the properties window here. Let's say this is SB1, this is the SB2, for example. You can see here I put a name on it, and the truncated horizon is the SB1, which is the red one in this case, and the SB2 is the reference horizon. I can also modify the thickness threshold, which is the third parameter here. So I would reduce it to, let's say, 60. or maybe 40. You can see when I decrease the thickness threshold, the thickness from which the truncation occurs appears lower. Okay, I can put it back to the 100. And then I can modify the distortion strength as well. So let's say I want to change it to 5. So you can see the truncation became more aggressive. You have a more like steeper slope of the truncation here. And then if I want, I can also visualize the effects of a truncation on a 2D map view. So to display the horizon map viewer, I will click on the horizon map, which is located on the far right side of the viewer here. Here you can see this is a thickness map. It shows you the thickness between the truncated horizon and the reference horizon. The values were mapped on the truncated horizon in this case, which is the yellow one on the seismic section here. And also on this map, you can see there are 2 polylines. The first one, which is the blue one here, this is the thickness threshold polyline. It shows you where the truncation starts. And the second one, which is the red one here, it shows you the exact places where you have the truncation. So I can navigate using the cross navigation mask mode to cross navigate on the thickness map. I can change the distortion strength back to default, which is 1. And then I can use the cross navigation mask mode to navigate on this red line of the thickness map. You can see this is the exact location where you have the intersection between 2 horizons. You can also see it on the seismic viewer, which is this one. And beyond this red line, this is a huge area. This is a 0 thickness area where you have the truncation. I can also navigate on the blue line, which is the thickness threshold line here. It's equal to 100 milliseconds. So this is the location where the truncation began. And all the areas with the thickness lower than this threshold will start to be modified by the truncation. I can play with the parameters. So let's say I decrease the thickness threshold to 50. You can see the truncation cover less area than 100 millisecond thickness threshold. I can increase the thickness threshold back to 100 milliseconds. You can see the truncation cover more area here. And also with the distortion strength, when I increase it to 5, you can see the red polyline moved closer to the blue polylines here. That means you have a steeper truncation slope. In this case, you can see on the seismic viewer, the truncation is more severe. I can change it back to 1. And then you have a more gentle slope truncation. Alright, once I'm happy with the truncation I just made, I can go back to the 3D viewer to define more truncation areas. I can close this truncation list and this horizon map view as well. At this step, if I want to create more layers, I can use again the sequence picking tool here, drag inside the 3D viewer, and double click to define a new layer. After that, I would choose the truncation mouse mode again, repeat the same process. I put the cursor at the location I want to have a truncation. At this time, I would choose the truncation bottom to define some on-lap areas here. And you can see here, I have some on-lap and down-lap areas in this layer. Again, I can go to the truncation list and edit the thickness threshold or the distortion strength. And I can also bring the horizon map view for this truncated horizon I just made. And if I'm not happy with that, I can remove it by clicking on this remove button here at the bottom left of the viewer. And also in this tool, I will have an option to truncate multiple horizons in one attempt. To do it, I will need to select them first, in the selection mouse mode, I hold down Control and double click on the sequence boundaries in order to select them. They should be highlighted in red color like this. After that, I would go to the toolbar and select the multi-truncation top or multi-truncation bottom here. If I choose the multi-truncation top, that means the uppermost sequence boundary will become a reference horizon, and these below sequence boundaries will be snapped to this top one. And vice versa, if I choose the multi-truncation bottom, the bottommost horizon or boundary will become a reference horizon, and this above sequence boundary will be truncated to this one. In this case, I would choose the multi-truncation top for these selected sequence boundaries. A new window pops up. I can define the thickness threshold for each sequence boundary. So let's say 60 for the first one. So 120, not 60, for example. And then I hit OK. You can see here on the structure viewer, the truncation was applied. And I did truncate multiple horizons in one attempt. I can also bring you the truncation list in order to modify the thickness threshold or the distortion strength for each truncation. I can also bring you the horizon map in order to view the truncation on the 2D map view. The first product I want to generate from this truncated sequence is the horizon stack. So this is the option here on the toolbar, a new horizon stack from sequence. I click on it. So this is different from the traditional horizon stack because this one only made of the sequence batteries, including the truncated ones I just made. And as usual, I can map any seismic attribute on this horizon stack. For example, I would choose the envelope attribute. I can put a name on it and then hit OK, hit run. And actually, I did generate one horizon stack for you, which is this one. So this is made of the sequence boundaries and also the truncated horizons I just made. I can navigate on the horizon stack viewer to see where I have the truncation. Title the window a bit. You can see here the intersection of the horizon stack viewer is yellow on the strata viewer here. I can move up and down to see all the sequence boundaries and the truncated boundary I just made. I can also display this horizon stack in 3D viewer. You can see here, I can drag and drop the seismic volume inside this 3D viewer. I can scroll up and down the stratigraphy to see all the sequence boundaries inside this horizon stack. You can see it's honored nicely the truncation I defined before. The second outcome from this truncated sequence is a new type of GeoModel, which is honored the truncation geometry I just defined in this strata viewer here. So the option is on the toolbar, which is edit or create a GeoModel from sequence. Just click to open it. You can see here, this is a list of the sequences I defined previously. The lithology symbol as well. And then I will have an option to define a new model type for each sequence. These options are isoproportional, parallel top, parallel bottom, or I can use the original RTT model for my sequences. Then I can put a name on it and hit OK. So I had a GeoModel created beforehand. So I'm opening it now. You can see here the geometry of the new truncated GeoModel respects the truncation I've made in the strata viewer. I can navigate inside this new truncated GeoModel here to show you where I have the truncation. You can use this new truncated GeoModel as an input to generate a new type of parent stack, which also follows this truncation in the StratiViewer as well. Alright, that is the new tool in Paleoscan. Thanks for listening. Please let me know if you have any question related to this feature. We'll be very happy to support you on this. Goodbye and hope to see you again soon.